And we're live. What's going on YouTube? How's it going? So today is day 11, relearning linear algebra as a hobbyist. I am the math hobbyist. There's my email in case anybody wants private tutoring. I want to say that right now before I forget, because I get so excited, geeked out about these problems that I forget to talk about that. So I'm available as a private tutor if anybody wants that. And with that out of the way, let's just jump into one of these problems. But yeah, so actually, right before that, I just want to try to give like a couple little life updates each day at the beginning of these videos. I want this to be sort of like a vlog, and I'm trying to make them a lot shorter. The last videos, like yesterday, we did linear algebra problems for 3 hours. We did a 3-hour linear algebra stream. Nobody's ever going to watch that after the fact, and I'm too lazy to go back and edit it into small videos. So let's try to make these short and snappy. Let's shoot for 10 minutes. So to that point, Siri, set a timer for 10 minutes. Hey Siri, set a timer for 10 minutes. Let's see if we can do it.
10 minutes, counting down.
Thank you very much. All right, so let's see how this goes. Here's Shilov 1.8. While I was in Cancun, I solved a bunch of linear algebra problems from this fantastic book, Linear Algebra by Georgy Shilov. The book got super warped with all the humidity. I was just hanging out on the beach doing problems on paper in this tiny little notebook. I had so much fun. And then the other thing that I did was really reading this book, and I got so far into it. It is fantastic if anybody wants a book about design. So, yeah, I've got a lot of free time. I'm a software engineer. I studied math 15 years ago, and now I'm relearning it just for fun. And, yeah, so let's just jump into it. Here is a determinant problem. Calculate this determinant. 1, 1, 2, 3, 1, 2 minus x squared, 2, 3, 2, 3, 1, 5, 2, 3, 1, 9 minus x squared. So, pause the video right now. Pause. Have you paused? I'm going to show the solution. So, try to work it yourself. All right, let's show the solution. First, a hint. P of x is obviously a polynomial of degree 4. We first find its leading coefficient and then determine its roots by making rows of the determinant coincide. So I have solved this one on my own. So I always try to solve a problem before looking at the back of the book. Here's the answer. P of x is negative 3 times x squared minus 1 times x squared minus 4. All right, so Shilov is a lot of really great practice on determinant problems. It's really the opposite approach of Sheldon Axler. So let's just jump into it. We are going to use the, I want to write out a little tiny bit of theory as we do this. Where is it? I'll write what math fact we're using, what theorem we're using as we go. But in short, you can subtract and add multiples of columns or rows to a row or column in the determinant. That's one fact. And then another fact is you can interchange, you can swap rows or columns, and it will keep the value of the determinant the same, but change the sign. So those are the two facts that we're really going to use. I don't want to add more copies of the x squared term, so I'm pretty much going to just be trying to fix those two. I want to fix this one and fix this one, the second and fourth columns. I'm going to solve this in columns because that's how Shilov does it. But yeah, so let's do column 4 minus column 3, and I want to do column 2 minus column 1. So column 2 minus column 1 is going to be 0, 1 minus x squared, 1, 1, right? I'm just going to repeat this first column. And then maybe I'll also do column 3 minus column 1. So, well, let's do column 3 minus 2 times column 1. Column 3 minus 2 column 1. That way, 2 minus 2 is 0, 2 minus 2 is 0, 1 minus 4 is negative 3, and then 1 minus 4 is negative 3. And then finally, we have column 4 minus column 3, and I can, use the column 3 from the prior version of the matrix. So 3 minus 2 is 1, 3 minus 2 is 1, 5 minus 1 is 4, and then 9 minus x squared minus 1 is 8 minus x squared. Okay, you still with me? Now what can we do? We can also operate with rows as well. So I'm going to take the second row and do row 2 minus row 1, and I'm going to do row 4 minus row 3. That way we have 1, 0, 0, 1, 0, 1 minus x squared, 0, 0. Let's just keep the third row the same. 2, 1, minus 3, 4. And then finally, row 4 minus row 3 is going to be 0, 0, 0. And then 4 minus x squared. Okay, now this is looking pretty nice, I think. This is looking pretty good. We've got a lot more zeros, and that's going to make this matrix a lot easier to calculate. But I do want to do one last one. We can do row 3 minus 2 times row 1. A gotcha is, remember that when you replace a row, don't do any multiples of the row that you're replacing. It needs to be the row that you're replacing plus or minus a copy of another row, and likewise with columns. So row 3 minus 2 times row 1 is going to be 0, 1, negative 3, and then 2. Now we've got a nice column of zeros in the first column, and everything else is the same. 1, 0, 0, 1, 1 minus x squared, 0, 0, 1 minus 3, 2, and then 0, 0, 4 minus x squared. Now I can expand by cofactors by column 1 cofactors. Okay, and I'm going to write this out so that people see the full theory of what's happening, but it is going to be simpler than, I wouldn't normally write out the whole thing. This is going to be the first entry times the determinant gained by removing the first column and the first row. Okay? So that's 1 times this determinant, 1 minus x squared, 0, 0, 1 minus 3, 2, 0, 0, 4 minus x squared. Oops, running out of space. Right there. And now plus 0 times another determinant plus 0 times another 3 by 3 determinant plus 0 times another 3 by 3 determinant. I'll write the second one, but clearly we can see that all of these just zero out because the determinant is a number, and then any number multiplied by 0 is going to be 0, right? So that's fine. But I just want to show, again, how does this work expanding by cofactors. So, again, we're expanding by the first column, cofactors of the first column, and we have this antisymmetry property where the sign changes every other time. So it's going to be minus the cofactor times the determinant of the minor matrix plus another cofactor times the determinant of a minor matrix, and then minus. So plus, minus, plus, minus. And the matrix that would be used here, or it is the determinant that we're going to use, but we're going to multiply it by 0, so who cares? 4 minus x squared. All right, and then whatever... Oops, I forgot about batteries. Batteries are a thing. All right, that's even more pressure to finish this in 10 minutes. Whatever that determinant is, it is going to be multiplied by 0, so we don't care about it. Now, this first one, let's expand by the first row. Don't write lines like this in your homework. That's not really standard notation. I'm just doing that to show what I'm doing here. But this is going to be 1 minus x squared times this 2 by 2 determinant, negative 3, 2, 0, 4 minus x squared, right? And then again, 0, 0, so I'm not even going to write the other terms. And now this is 1 minus x squared times this 2 by 2 determinant, which we have a nice formula for. Okay. Again, the reason for this is that a 2 by 2 determinant, A, B, C, D, I always see it as this diagonal multiplied together, AD, and then minus this other diagonal, AD minus BC. So that's what I did here. Minus 3 times 4 minus x squared, and then subtracted 2 times 0. And then we get the answer that's in the back of the book. I think that we took a different approach than what Shilov is recommending, but 4 minus x squared and 1 minus x squared. Personally, I always like to have x squared as the leading term. I think that that's the more standard form of a polynomial. So if we factor out, if we multiply the first term, or the second term and by -1 and the third term by -1, well, you multiply it by 2 -1s, so the sign doesn't change. This is the same as x squared minus 4 times x squared minus 1. And we are done. Boom. There it is. Yep, and that's how he wrote it as well. X squared minus 1. Well, yeah, that would have been even nicer. x squared minus 1 times x squared minus 4. But it's the same thing. It's the same thing. We got the right answer. Thank you for watching this little tutorial. My name is John, also known as the Math Hobbyist. I would love to build up a really cool community here in the stream. So come swing by sometime. Leave a comment below if you enjoyed it. Comment, like and subscribe, all that good stuff. Like and subscribe. And let me know what kind of math you want to see me work. So here's our little short video for today. Less than 10 minutes. Siri hasn't even gone off. And I'll be back in a short little bit of time. And next, I'm going to do a longer stream, live studying. So that is the concept of this channel. It is a practice stream. I'll just be working through problems, reading theory. Soon, probably this week, I want to be learning about Markov chains, which is an application to linear algebra to the real world. We can build things like ChatGPT if we use Markov chains. So, thank you for watching. Like and subscribe, and have a beautiful